I'm Jinhua Sun from Chalmers University of Technology, and over there I'm working on graphene. That's why I'm in this project, that is the ARMS project. This is a graphene flagship funded project. In total we have 11 partners from 6 countries around Europe. From my side in the project is to coat graphene and carbon fibers to increase the surface area conductivity for the structure battery, because if we use carbon fiber as a structure materials for energy storage, but their theoretical capacity is not good enough, so that's why we can use graphene to increase the surface area conductivity. And over there our strategy is to have this vertical graphene on surface carbon fibers, and then we can have more exposed surface area, and then to allow the second step to deposit active material, for example the metal oxide, using the ARD method. In this way we can further increase the energy density or the capacity of the fabricated supercapacitor. And this is only one supercapacitor that we are going to make, that is structure and maybe flexible supercapacitor, but another one is a more standard supercapacitor with higher energy density. But over that one we also use graphene to increase the capacity of the traditional materials. There are broad applications of the supercapacitor that we are going to make and made by the graphene. For example, within the project, we also have the end user, that is the drone company, and then we can use this structure supercapacitor to power the drone and then make it fly faster and longer. And because for the drone, the weight is the matter, and then we want to reduce the weight of this energy storage device, that is a supercapacitor in our case. And but beside this application, there are also many other applications for the battery, for the supercapacitor that we made based on graphene. And I think this will be very important for the future energy storage.